Continuing with section 6.3. So in the last video I showed you how to derive this formula for the volume by using cylindrical shells. Recall that for this formula to use, we have to check whether the revolution is about the y-axis or the x-axis. If the revolution is about the x-axis, then this second case is what we are looking at. Then the integral will be in terms of y, and so we will be integrating with respect to y. But if you revolve the region about the y-axis, then the integral will be in terms of x, and we will be integrating with respect to x. So this is something different than what we had in disk and washer method. In those methods, when we revolved our region about the x-axis, then we were integrating with respect to x-axis. And if the region was revolved about the y-axis, we were integrating with respect to y. So this is a big difference between these two methods, this disk and washer and then cylindrical shell. Okay, let's look at some examples. The first example is using the cylindrical shell method. Find the volume obtained by revolving the region bounded by these two, y is equal to x and y is equal to x square, about the y-axis. So note here y-axis. So we just learned that if we are going to revolve about the y-axis, our function must be in terms of x. So we have this one in terms of x, this one, so we are good. Okay, let's try to draw them. Okay, so one is just y is equal to x, which goes like this, and the other one is x square, which goes something like that. So we know that they intersect at 1, 1. So this point is 1, 1, and this point is 0, 0. Also, we can check our the limits. We know they will be from 0 to 1 because we are going to integrate with respect to x. Remember, the formula that we are going to use is v is equal to integral a to b 2 pi x f of x dx. Okay, so what is f of x? This is the height, and then we go like that. So what is the height here? So there are different ways you can do this problem, like you can do the writing, but basically, okay, let us look here first. Let's complete this. So if we revolve about the y-axis, so I will get a like that here, right? So then our this will be our cylinder, like that. Okay, so what is the radius? That is going to be x, because we are revolved about the y-axis, and the height will be the difference between these two. So our integral limits will be that we set these two equal to each other, factor, we have those two. So our v will be equal to integral from 0 to 1 2 pi x, and then times f of x. F of x is actually going to be the difference. So we have to check which function is above here in this piece you see x is above x square, so x minus x square, and then dx is equal to, so this is a simple integral, 2 pi outside, integral from 0 to 1, x square minus x cube dx. So basically it's the setting up is the main thing. The integral is quite simple, 0 to 1 x cube. Okay, so I am integrating now, so I should not have this thing here. X cube over 3 minus x4 over 4. Limits from 0 to 1 equals 2 pi. Plug in the limits. So 1 to the 3 is 1. So 1 over 3 minus 1 to the 4 power is 1. Minus, let's check the other limits, 0 minus 0. So we end up getting 2 pi. Don't forget the 2 pi. And then inside 4 minus 3 over 12 minus 0. This is gone and we are left 4 minus 3 is 1, so I had 2 pi into 1 over 12 or pi over 6 is our answer. So the volume is pi over 6. Okay, looking at the next one. So it says using the cylindrical shell method, find the volume obtained by revolving the region bounded by x is equal to square root of y, y is equal to 1 and y is equal to 4 about the x-axis. So remember, if we are using the cylindrical shell method, then and the region is being revolved around the x-axis, then our function must be in terms of y. So do we have, this is in terms of y, yes, and then we are given the limits on the y. So let's see what it looks like when we graph it. Remember, if x is square root of y, then it means y is equal to x squared. So it means x squared, this type of function, and then it says going from 1 to 4. So remember, it is when y is 4, x will be 2. When y is 1, x is 1. This is 2. Something like that, but then we have cut it, so only this portion is our portion, and then we are revolving it about the x-axis. So this is what it looks like. This is -1 here, -4 somewhere here, so now the cylinders will be sideways. This will be a typical cylinder. So notice here now radius will be the y because it's a vertical distance and the height is horizontal distance. So it will be now limits. The first thing is limits, they are already given, so we don't have to, because also we have only one function given here, so we can only use these limits. So we say v is equal to 1 to 4 2 pi y into square root of y dy. So again, this is pretty simple. 1 to 4, 2 pi y to the 3 halves. 2 pi y to the 5 halves divided by 5 halves, which becomes 2/5. So it becomes 4 pi over 5, and then 4 raised to 5 halves minus 1 raised to 5 halves. Now 4 raised to 5 half means 2 raised to 5, because the 1 half is square root, which makes 4 2 minus 1. What is 2 to the 5? It's 32. So I get 32 minus 1. So my final answer will be, okay, so I get 4 over 5 pi times 31, which can be written as 124 pi over 5. That is the volume. Okay, I think I will stop here and do the rest in the next video.